Okay, so let's look at gain in decibel. Um, Remember, gain when you calculate V output over V input, it is a unitless quantity. Of course, input voltage and output voltages. The unit of both voltages is volt. So when you take the ratio, you cancel volt out, and the gain is always a unitless quantity. All right. Remember that. Never put any unit with the gain if you're taking the ratio between the same quantity, like current gain or voltage gain, right? There will not be any unit associated with that. Now, most of the time you must have seen music systems or other things that gain is given usually in decibels. So generally, practically, gain is given in decibels. Um, Filters, when we study filters, the gain is also given as decibel for those filters, active filters that we are going to study in this course as well. So what is decibel and how do you convert a unitless quantity gain into decibel? Very simple, as you can see on the screen. All you have to do is whenever you have a gain value, you take the log 10 of that gain if it is voltage gain or current gain. You take log 10 of that and then multiply that by 20. So log of the gain to the base 10 multiplied by 20. That's how you convert the voltage gain and current gain into the decibel value. For power amplifier, this is incorrect. I'm going to fix it. For power amplifier, it is 10 log 10 of AP. All right, 10 log 10 of AP. So if your voltage gain, of course, is V out over V in, you will substitute this over here. Current gain, substitute over here. Power gain, substitute over here. And remember, when you're in the logarithmic scale, your multiplication becomes addition and your division becomes subtraction. So basically, if I want to write this down, it's going to become 20 log 10 of V naught minus 20 log 10 of V input. Okay, so the division V out over V input, you can write that down as the subtraction between the decibel value of the output voltage. This is the decibel value of the output voltage, right? 20 log of V out minus the decibel value of the input voltage. Okay, and same you can do for the current amplifier and power amplifier. So anytime you have multiplication and you're taking the logarithm of that multiplication, you can change the multiplication operation into an addition operation, and likewise division operation into subtraction operation. So observe over here, if your total gain of the amplifier, if you ignore all the loading factors, and total gain of the amplifier is A1, A2, A3, A4, and if you want to represent that gain into decibel, then you're going to take 20 log 10 of A, which is 20 log 10 of the product of all gains, and you can write that down into addition, 20 log 10 of A1 plus 20 log 10 of A2, and so on and so forth. And this is basically what A1 in decibel, this is A2 in decibel, and so on and so forth. So basically it is your total gain in decibel is the sum of the total gain, sum of the individual gain in decibels. Okay. Alright, if the gain is less than 1, it is called attenuation. Or attenuation is basically reciprocal of gain. So attenuation is 1 over gain. Anytime we talk about attenuation, that means our gain is less than 1. If your gain is less than 1 in decibel, the gain is going to be negative, right? Because you're going to have, let's say, 20 log of, let's say, 0.1. That's going to be a negative value. Anything log of 1 is 0, and anything below 1 is going to be negative, right? But for attenuation, if attenuation is positive, that means your gain is negative. Positive attenuation means negative gain. Negative attenuation means positive gain. Alright, so the expressions that is given over here, 20 log 10 of attenuation, which is 20 log 10 of 1 over gain, which we can write 20 log 10 of 1 minus 20 log 10 of gain. Log of 1 is 0. So attenuation in decibel is basically negative of gain in decibel. And we use attenuation very frequently. Now, the problems that will be given to you, if I give you a problem in the quiz or in the exam or even in the homework, if I give you some gain values to be in decibels, some gain values to be in a unitless quantity, make sure, I will advise you that for me, I think I feel comfortable if I convert everything in the unitless quantity and then calculate the total gain of the circuit, including the loading factors and all those things. You can also convert everything in decibel, including the loading factors in decibel, and then you can perform the calculation in the decibel scale. That is, all the multiplication are going to become addition, division are going to become subtraction. Generally, I feel it is easier if I convert gain from decibel to unitless quantity and then proceed from there to solve any problem. And remember, how do you convert decibel into unitless quantity? So for example, you have let's say 30 decibel is your voltage gain. Let's say AV in decibel is 30 decibel. Okay, that means 30 is equal to 20 log of 10 of AV in unitless quantity, right? So 30 divided by 20 equals the logarithm of AV, and let me do it here. I keep doing everywhere. I should not do that, but anyways. And how do you get rid of the log? You take the power on both sides by the whatever the base of the log is. So base of the log is 10. You're gonna take power 10 to the power 30 over 20, or 3 by 2, 3 over 2, and that's going to be equal to AV. So I don't think I mentioned it in the notes, assuming that everyone know how to convert, how to go back from the logarithmic scale to the regular unitless quantity. But if you forgot about it, then this is how you're gonna go back, basically. Okay. All right, there's an example that I'm giving you. Go over that example. I don't want to, read the example. You can do it, and then you can understand. It's pretty straightforward. And in the next, we can discuss frequency response.